Okay, here we go. Chapter 2-2. I saved this one to be one of the easier sections to go along with the regression because regression is so involved. So today's lesson, super duper easy. Stay with me. Direct variation. When an equation has b equaling 0, then we have an equation in the form of y equals mx. Meaning if we have the equation y equals mx, that's implying that your b value is 0, meaning your y-intercept is 0. Do we understand that? Okay? In other words, it goes through the origin every time. Except for that one. The big origin. Okay? That's what all of the lines are going to look like. They all go through the origin every time. Now, how do you know, given something, if it is going to be direct variation, if it's just an equation? Well, y equals negative 3x. Is there a b value there? Is there anything attached to it by addition or subtraction? No, so then this is direct variation. It is direct variation. dv means direct variation. Now, y equals 3x minus 2. Is this direct variation? No. No, it is not. Why? Because it has a 2 there. Okay? What if it doesn't give it to you in that form? What if I gave it to you in this form? Is that direct variation?
No.
No, because you should only have an x and a y, correct?
Yeah.
So this is not direct variation. Do we all understand that? That is like problems 4 through 9 tonight. On tonight's homework. Slide 4 through 9 on tonight's homework. We good? Damien, we good?
Yep.
Okay, next. If the linear function or a straight line is direct variation, then for any two ordered pairs, x1, y1, and x2, y2, then the following is true. y1 over x1 is equal to y2 over x2. What does this look very similar to? Slope. Slope. You're pulling out the subtraction sign, and in place of subtraction, you're putting a equal sign. Do we understand that? So if you know the slope definition, you already know the ratio definition. Does that make sense? So what we're going to do here is we're going to simply label our points. This is x1, this is y1, this is x2, this is y2. So what do I do here? Plug and chug. y1 over x1 is equal to y2 over x2. When I plug and chug into my formula, we're writing this all down. y1 is going to be 5 over x1, which is 7. y2 is 2 over x2, which is x. Do we all see that? Yes or no? Now, when you have a fraction equaling a fraction, you simply cross multiply. Very good. So 5 times x is equal to 7 times 2, which is 14. Now, what am I solving for?
Divide by 5.
I'm solving for x, so I simply going to divide both sides by 5. So I get x is equal to 14 over 5. Done. Easy? Easy peasy, right?
Are they always going to have an X?
Or a y. For example, this one has a y. So what do I do? Step 1,
Label it for.
label your points. x1, y1, x2, y2. Then what? Write down your formula and plug and chug into it.
3 over 2.
3 over 2 is equal to y over 10. Now what do I do?
Cross multiply.
Cross multiply.
3 times 10.
3 times 10 is 30. 2 times y is 2y. Divide by 2. 15 is equal to y. Yes?
What?
You got on me because you thought I'd lose. Like,
You
what
remember
I know. I know that. I did it in my head.
Now, this is exactly off tonight's homework. This is number 10 in tonight's homework. I'm not giving it to you in ordered pair form. I'm giving it to you in the English language. So how do I go about finding this? It says if y equals 3 when x equals negative 9.
So it's
So it's X is
It's
negative.
still an ordered pair, right?
Y is 3.
So I have negative 9, 3, and then it says, and then find x. Do I know it?
Yep.
Nope, it's x. when y is 5. So it's exactly the same problem.
You're trying to make it hard,
I'm
but.
Trying to make it hard by adding words, but I just couldn't make it hard.
Come up with our own language.
So I have y1 over x1 is equal to y2 over x2. So that's going to be 3 over negative 9 is equal to 5 over x. Now notice the 3 over negative 9.
I can use.
That can be reduced. And I'm going to reduce it because you guys constantly cross multiply without reducing, so I'm going to reduce first. To give you negative 1/3 is equal to 5 over x. Now where can I put that negative at? It can go to the top or the bottom, right? I'm going to put it in the bottom. You know why? Because I don't want to multiply x by a negative, do I? Of course not. So I'm simply going to have 1 times x is x, and negative 3 times 5 gives you negative 15. No work required, it's done. Well, good. I'm glad you guys think that one's easy, because now let's go ahead and do the next one. If y equals 5 over 17 when x is 10, then find y when x is 5.
10 and 5, 17.
10 comma 5 over 17 and
5.
5 comma y. Good. Well, that's a beautiful thing. They're still just ordered pairs. So now I write my ratio. 5 over 17 divided by 10 is equal to y over 5. Holy shnikes.
Oh.
Right? Put the 10 over 1. I'm going to do a little sidebar here.
I don't know what's going
And I'm
on.
going to say 5 over 17 divided by 10 over 1. Do we see that? Because I want to make it divided by, I want a fraction divided by a fraction. Because when you take a fraction and divide it by a fraction, what are you actually doing?
Multiplying by the
You're multiplying by the reciprocal. So I have 5 over 17 times the reciprocal of 10 over 1 is 1 over 10. And what can I do now? The 5, nope, don't cross multiply, cross reduce. The 5 turns into a 1, the 10 turns into a 2. 2. Marry the tops, 1 times 1 is 1. Marry the bottom, 17 times 2 gives you 34. So what this means is this big, huge, ugly problem over here, this junk on the left, is actually the same thing as 1 over 34 is equal to y over 5. Do we see that, yes or no?
Yeah.
Make sense? Because now what can I do? Cross multiply.
That's a good one. That's good.
I do have to add the crazy ones as good as without you. It's fun. Okay?
For me, it's nasty.
So 5 is equal to 34 times y. Now how do I solve for y? Divide by 34. And I get 5 over 34 is equal to y. And this is one of your homework problems. Isn't that nice of me to do that one for you? Is that nice of me?
Yeah.
Yeah. Okay. Was this as hard as what you thought it was?
So,
Whoa. Let's back that train up then. What are you confused about?
5.
This right here is the same thing as 1 over 34. They are one and the same. It's like taking and giving you a nickname. Instead of calling you Sierra, we call you Little C. Little S, sorry. Okay? Do you see that I took that numerator, which is 5 over 17, and I divided it by 10, which is my denominator. I put the 10 over 1. When I divide by a fraction, I multiply by the reciprocal. The reciprocal of 10 over 1 is 1 over 10. Then I cross cancel and marry the tops and marry the bottoms. That's all I did. And you can get all of that with your calculator. If you understood the example before, I'm not concerned because this just means you're not liking fraction stuff. This doesn't mean you don't understand today's lesson. It means you don't like fractions. I know.
not
Okay.
why I love them.
Moving on. Recreation is always an equation. Recreation is the equation with b equals 0 always. It cannot be anything else. Okay? What you need to know is that it's y equals mx. However, mathematicians, we get our giggles by changing the letters around. and renaming things that we already know as slope, we rename them and make them a different letter, such as k. So if I say y equals mx, it's the same thing as y equals kx. What they call k is the constant of variation. We would call it the slope, but they call it k, which is the constant of variation. In other words, it is what changes your x value or your y value every time is what your slope does. You can call it m or slope in your head, but I'm going to say what is k, your constant variation. You need to identify that and say, hey, that's just my slope. Because m is what they use about the majority of the time. K is only the constant of variation for direct variation.
That's slope.
I know. K is what? Slope. K is slope. K is m. Right? K is slope. Now, you're right. However, that's not what I want you to do here. What I want you to do is come up with a formula for K, which is also known as your slope in direct variation. So if I want to solve for K, I need to do what with that K? I need to divide it by X. So I'm going to have Y over X is equal to K. In other words, anytime I'm given a point, I can immediately find my constant of variation or my slope. Do we understand that? By taking my y coordinate and simply dividing it by my x coordinate. So this is my formula. Now how do I apply that? Are you ready? It says determine whether y varies directly with x. If so, find the constant of variation, which is what? K. And write the function rule. The function rule is what? Y equals kx. That's the function rule. Okay? Now, in order to be varying directly, what this says is your k value, which we have determined to be y over x, has to be exactly the same for each ordered pair. Let me repeat myself. Your k value, which is y divided by x, has to be exactly the same ratio for each ordered pair. So let's do that for each ordered pair. What is negative 2 over 1?
Negative 2.
Negative 2. What is negative 8 over 3? Negative 8 thirds. Now my question to you is negative 2 equal to negative 8 thirds?
No.
Not in this lifetime or any other, I'm sure of it. So since these are not equal, this is not direct variation. Do we see that? Yes, do we see that? Which means I don't have a k, which means I don't have a function rule. Do we get that, yes or no?
Yeah.
Okay. Same exact concept on the bottom, but we have new ordered pairs. So what do? I need to find k, which is going to be y over x. So that's going to be 6 over 9. What does 6 over 9 reduce down to?
1/3.
No.
2/3.
2/3. So that gives me 2/3. Now what's 8 over 12? Do they both reduce down? They're both divisible by 4. 8 divided by 4 is 2. 12 divided by 4 is 3. Does that work? Good. Go to the last one. What's 10 divided by 15? They're both divisible by 5. 10 divided by 5 is 2. 15 divided by 5 is 3. Do I have the same k value for each ordered pair? Yes, which means k is 2/3. Do we see that? Which means my rule is going to be y equals kx, which means I have y is equal to 2/3 times x. I need to find both of these pieces of information. Do we get that, yes or no?
Yeah.
Now, I give you determine the direct variation equation through the point 6, 5. It is direct variation, which means y is equal to kx. That's your equation. What does k always equal? Y over x. Do I have a y and x? What's y?
5.
What's x?
6.
So now I take that and I plug it into my equation. Y equals 5 over 6x. There is my equation.
That's it.
That's it, dude.
That's it, bro.
That's it. We good?
Yeah.
That's it.
If I do that as Anytime you zoom out, I'd be saying your name the entire period.
Sorry.
Good.
Okay, same exact thing. Okay? What is my K? Y over X is my K. What's K? 15 over -7. So now I'm going to say Y is equal to KX. So what's K again?
15 over -7.
Done.
Wait, what's the negative?
Doesn't matter where you put the negative. I mean, the top, bottom, the middle. Cannot be both of them. Because then it would be positive. It can be middle. Okay, last one. How many of you are shut down already because you see words? Okay, well stop shutting me down and open your head up again, okay? No. When a bike is being pedaled in a certain gear, it travels 10 meters for every 4 pedal revolutions. Are we watching? I'm on my bike. You ready? My hands are my wheels, okay? 1, 2, 3, 4. What happened?
You travel 10
I
meters.
moved 10 meters, didn't I? Supposedly. I did.
Probably not, though.
Okay. Now, which one was dependent upon which?
However many times your feet went up. Every time you went
Every time I did a pedal revolution, I moved. So my distance depends upon what? My pedal revolution. So I have two concepts going on here. I have revolutions and I have distance. Do we understand that? My independent is going to be my lovely little revolutions, which means since it's independent, that's my x coordinate. My distance is going to be what's dependent upon my dependent, and that's going to be my y. Because my y value depends 100% on whatever x is. Do we understand that? So what we have going on here is we have 4 pedal revolutions is paired with 10 meters. Do you see the ordered pair? Read the next sentence. How many revolutions would be needed to travel 500 meters? X and 500. Do we see this? This is exactly like the first 3 problems we did in here.
Wow.
So how did we do that again?
Y.
Y1 over x1 is equal to y2 over x2. Remember that? So I have 10 over 4. Good job. Now I'm going to reduce this because 10 over 4 reduces down to what? 5 over 2 is equal to 500 over x. So 5x is equal to 2 times 500. Why did I do that? Because do we like to deal with big numbers or small numbers? Small numbers. I'm going to see if anything cancels out. Divide by 5, and x is equal to, well, that becomes 1, and this becomes 100. So what's 100 times 2? 200. What is x again? What does x represent? So what is it? Your pedal revolutions, right? So I have to have 200 pedal revolutions to travel 500 meters. Do we understand that? Okay, tonight for homework is this lovely, lovely little worksheet. Lovely.
Well, apple.
Yeah.
Okay, now, problems 1 through 3, it says for each function, determine whether y, quit talking. You can't hear me if you're talking. I'm passing out graph paper because you guys also need graph paper today. Oh, I hate it.
Where is my notebook thingy?
You do? Why? Why?
Okay. Now, problems 1 through 3, it says for each function, determine whether y varies directly with x. So you're doing your k values and making sure your k values are equal. Problems 4 through 9, it says determine if it varies directly with x. In other words, it's a direct variation. Look for a b value. Problems 10 through 13, we did 2 of those already for you. 14 and 15 are just like it. 16 and 17, it says make a table of x, y values and use it to graph the direct variation equations. You have to graph them. So plug and chug. For problem 16, what type of values of x should you use? Well, I have 1 over 5 times x. 1 over 5 times x. What makes pretty numbers? Factors that are divisible by 5. So I want to use negative 5, positive 5. Negative 10, positive 10, right? Because if I take 5 and divide by 5, it gives me 1. If I take 10 and divide by 5, it gives me 2. Do we see that? Now, for 18 through 21, it says write and graph direct variation equation. If we're looking at number 18, it gives me the point 62. So what's my equation? Y is equal to kx. So what's k?
6.
2 over 6x to give me 1/3. So guess what? Start at the point 0, 0, and my slope is going to be 1/3. So that's up 3 or up 1 and to the right 3. That's easy, right?
Wait, what ones do we have to graph? 16 through.
We have to graph 16 through 21. Any questions on tonight's homework? Okay, the rest of the time is yours.
When do we get out of here?
That's it.